Okay, we're going to finish up our lessons on magnets today with lesson 4, Earth as a Magnet. So you need this set of notes and you need your glue stick. Go ahead and open this up to the next blank page. And mine is facing our lesson 3. Yours might be on the back. If you would put your glue on there and get it stuck in, that'd be great. Okay. So we're going to look at Earth as a magnet today. So Earth is a large magnet. And I think we've talked about that in one of our other previous videos. But so in our notes, we're going to go ahead and write in Earth is a large magnet. The next note we have is a magnetic compass is an instrument that works with Earth's magnetic poles. We talked a bit about poles yesterday. Magnets have north and south poles, and they work with, or magnets work with those poles as well. So a magnetic compass, C-O-M-P-A-S-S, is an instrument that works with Earth's magnetic poles. So when you have a compass, the compass needle points north. It is attracted to Earth's magnetic north, so it points in that direction. Now, this last note is a word you may not have heard before, but a map, which we talked about in our last unit, and a magnetic compass can be used for something, which is finding your way when you are lost. The word we're going to put in here is orienteering. Orienteering, getting yourself oriented, finding your way. So here you're going to have to write a little smaller. O-R-I-E-N-T E-E-R-I-N-G. Boy, that's really small, Mrs. Medved. So orienteering. Orienteering is finding your way when you don't know exactly which way to go. So you can use a map. You can use this to tell you which direction is north, so then you can use your map. People also use the landmarks like mountains. One easy way for us to orient ourselves here in Pueblo and Pueblo West is we know that the mountains for us are west. So we don't actually need a compass. If we can see where the mountains are, we can always know which way is west, and then from there we can figure out the other directions.
So we're going to watch a short video on compasses, and then when we are done, you need to study your notes, because tomorrow on Thursday we're going to have a short test on magnets, because on Monday we're going to start a new unit. So once this is done, you need to study your notes, make sure you know the answers to the facts that we've filled in. So have someone ask you questions. You can ask other people questions and see if they know it, but you need to practice and know what's in your notes about magnets. Okay? So we're going to watch this short brain pop and we will be done.
You have to tell me to duck before you do that. Dear Tim and Moby, how does a compass work? From Henry. Compasses are pretty cool. Pretty much wherever you are on Earth, a compass points north. Compasses can help you navigate. Sailors rely on them all the time. Once you know what direction north is, all the other directions fall into place. Right now, we need to be going northwest. I think we're a little off course. A compass is a really simple tool. It has a small needle made of iron or steel. The needle is actually a magnet with a north pole and a south pole, and it's balanced on a smooth pivot so that it can swing around freely. Wherever the north pole is pointing, that's north. It works because Earth is really a giant magnet. It produces a magnetic field, an invisible area of force that extends all around it. That field makes a compass's needle swing into a north-south position. Hey, good question. With magnets, opposite poles attract and like poles repel each other. So how come the north pole of the compass's needle points north? As it turns out, the Earth's magnetic field is flipped. Magnetic south is in the geographic north, and vice versa. It's not as crazy as it sounds. The compass is a very old invention. It was developed before people had any idea how it really worked. They just knew that one end of the magnetized needle would always point north. So naturally, people began referring to the opposite ends of all magnets as north and south. Really though, they could have called it anything. A and B, plus and minus, whatever. Oh yeah, that's another little wrinkle. The magnetic poles are slightly offset from the geographic poles. That's because Earth's magnetic field doesn't run exactly along its rotational axis. The closer you get to the poles, the more this difference matters. If you're really far north, a compass may actually point you east, west, or even south. But the rest of us can still use a compass to get where we're going. We just have to account for the magnetic variation. That's the difference between a compass needle's north and true or geographic north. Let's see, from here, the variation is about 5 degrees west. In other words, the needle is pointing 5 degrees west of true north. So we just need to adjust our compass 5 degrees to the east. And then adjust our navigation until we're pointing the right way. You're too heavy, and you're not magnetic. You are magnetic? Duck.